Hello, I've been keeping an eye on the featured videos on David Weiss's Flat Earth Clock app. And since the release of the James Webb Space Telescope images that NASA put out back in, I think it was June or was it July, so about 2 or 3 months ago, I've seen a recent set of videos on the featured video list that I thought were kind of ridiculous and showed the mindset of the flat earthers. Check the description for a link to those videos. I'll make that available. But those videos inspired me to make this one. It started off with one video from Peggy Hall going on endlessly about various people hired by NASA to render the images, not just from JWST, but from other missions or other things that they do. For example, there was a web page that showed how an artist rendered NASA's best guess of what the surface of planet Proxima b would look like. But in the video from Peggy Hall, she showed massive quantities of incredulity regarding the images released from James Webb Space Telescope, and implying throughout the video that the images from JWST are somehow fake and concocted by NASA for some purpose. And I would just like to point out David Weiss, who seems to show contempt for others using CGI, seems to have no problem adding his own CGI to further his own agenda of promoting his Flat Earth Clock app. So that seems to be a bit of a pot calling the kettle black, I think. The next video may or may not be a composite of various other images that David Weiss pulled together, but it starts off with Level Earth Observer calling the images that were released by NASA as Tosh. What else would you expect from him anyway? The next part of this video showed someone spending several minutes using a graphics program that they had later referred to specifically as the Canva app for the iPhone to essentially build up what looked like a star field. And then in that same video, there was another segment that showed how someone looked at the metadata of the images that NASA released and showing that some of the metadata clearly indicated that it came from Photoshop. And then they go on to imply that somehow it's proof that all of the James Webb Space Telescope images were faked and very possibly extended to all of the images that NASA has ever released as being faked. The next video after that looks like it might be a clip from the previous video that had Level Earth Observer in it. And in this video, whoever made the video claimed that maybe NASA should hire them, and then it very much looks like it's a repeat of that other video clip that was shown in the previous footage. The next video that I saw was very much on that same theme, where it looks very much like it might have been David Weiss himself using what looked like the Canva app for a desktop to create another mock star field. And at the very end of this video, which makes me think it was Dearth, it zooms into a corner of the image that was generated and it shows David Weiss appearing to stand up. So in those videos, the incredulity is crystal clear. By the implication that some images can be faked, they are somehow implying that all images and videos that NASA releases must therefore also be fake because NASA has admitted that some of their images were photoshopped. In other words, is NASA going through all of this effort to make us believe that what they supposedly launched was really a satellite that was really launched in space? Flat earthers don't seem to be very subtle about their accusations of complete fakery, so I spent a bit of time scouring the internet for any evidence of possibly raw images that came straight from the James Webb Space Telescope that did not show any sign of doctoring or manipulation. And a whopping 30 seconds of Google searching later, I landed on a website that tells you how you can go about downloading the raw data that supposedly came straight from the James Webb Space Telescope. Check the description for the various links below. This should be one of those links as well. But it does clearly have a section that shows how you can go about getting the data that purports to have come straight from the James Webb Space Telescope itself. Just a little bit lower than that, for example, there is the old way that you can do it, and this is the link that I followed. I clicked on that link and it took me to this page right here. This allows you to download a shell script that will go and pull all of the various files associated with that JWST program ID. Of those first initial 5 images that NASA released, I found that the Carina Nebula was my favorite, and so that's the one that I downloaded. And I ended up clicking on this link to download the script that would download the calibrated data for NGC 3324. Keep in mind that that script will also download the raw data in a what looks like an uncompressed format, and those files can be quite large. I think each image is somewhere in the order of about 300 megabytes. I opted to modify the script to not download the raw data files, but just simply to download all of the other ones, including the JPEGs and whatnot, which seemed to come from those other data sources. So it just seems to be the original data converted into another format. So what are the sorts of images that you get for all of your effort? Well, the alternate format files, JPEGs in this case, happen to be a 2048 by 2048 image of just a small part of the Carina Nebula in this case. And if you zoom in, you can even see the horizontal scan lines, which could very well be an indication of an artifact from a charge-coupled device. But I'm going to talk about that part in a short little bit. Nevertheless, all of these various images do tend to suggest that they are, in fact, the raw data that came from the sensors on the James Webb Space Telescope. One of the other things that is extremely apparent when you look at the raw data versus the type of image that NASA has released is that the raw data provided is a very small section of that large nebula. So why would NASA bother photoshopping the images they released? Well, it should be very clearly obvious that they did that for practical reasons, because let's face it, a section of the sky that looks like this may appeal to scientists and physicists looking for new cosmological insights, but for the average public, it doesn't look very impressive or very dramatic. So part of what NASA does is appealing to the public. They have a team hired to take the data that they collect and to make it look more exciting and to give it a much larger wow factor for the general public. So then there was another video I saw after that, which also showed abundant amounts of incredulity over the images that were captured by NASA's older satellite, the EPIC satellite. And the images that captured were very similar in size and resolution to what the James Webb Space Telescope captures, which appears to be 2048 by 2048 or around 4 megapixels. And so they really made a really big deal in that video about how in 2015, when they launched the EPIC satellite, that the technology for cameras were already in the tens of megapixels. And in this entire video, they kept showing their incredulity and even contempt for what NASA did by a lack of study on the matter. So that brings me to my next point, which is how are these satellites built and what sort of operational requirements are required? So just for a very quick recap, it looks like the James Webb Space Telescope has kind of a base where everything is bolted onto. There's a set of solar reflective sheets that unfolded when they put it in place and they were setting it up. And that is to protect the satellite from the brightness of our own sun. There's a mosaic of reflective panels, kind of a gimbal that holds a reflector off in the middle over here to very possibly bounce the light through this hole and into the sensor that's in the back here. If you're interested in the construction of JWST, I will let you track that down yourself. But there are several of the main components to JWST which are really intended to measure the light in the infrared spectrum. So basically they're looking for the light frequencies that are on the infrared side of the visible light that we can see. Depending on the wavelength, some of those light frequencies can pass through dust and ice particles that are in space, whereas others that get closer to visible light get blocked by those particles. And so by looking at the various spectrums of light, they're able to gather the appropriate kind of knowledge as to what the obstructions were that blocked the light, and then they can also look at other things such as the electromagnetic spectrum from the various objects to kind of determine what certain planets or stars might be made of. In a very crude diagram sort of way, this kind of shows how James Webb Space Telescope works. The light from the reflectors comes in over here. The first thing the light has to pass through is the occulting masks. So there are two of them. One occulting mask is for the short wavelengths and the second one is for the longer wavelengths. It's unclear exactly how this works, but I suspect that the pupil wheel for these two bands are one behind the other so that the light would have to pass through both wheels or through one of these occulting masks from each wheel in order to continue. And then once it gets past the occulting masks, and I'm not exactly sure how this next section works, but it seems like the light is split into two different paths. One path would represent shorter wavelengths, and the other path would represent the longer wavelength. And the short wavelength channel would then go through one diachroic filter, and the long wavelength would then go through the other diachroic filter wheel. You can see that the near cam looks fairly complex. Then finally, presumably after it's passed through the filters, you have the sensor that is behind it. So this brings up a really interesting question, which is what sort of sensor would they put out in space? They certainly would not go to Walmart and buy a cheap compact camera, take it apart, grab the sensor and put it into a space telescope. There are certain requirements in space that we don't face down here. We have the Earth's magnetic shield to protect us from all sorts of deleterious radiation that is out in space. So whatever camera that they put out in space has to be able to withstand being bombarded by cosmic radiation. Depending on what type of satellite they're putting out, it might have a very wide operational temperature range. In the case of James Webb Space Telescope, it is primarily intended to focus on the stars, so it has to be fairly sensitive to low light levels. And unlike cheap consumer-grade cameras that focus primarily on trying to take pictures that are as photorealistic as possible, they want those sensors to capture a very, very wide range of wavelengths, which means that they are not going to include an ultraviolet coating to block out invisible light frequencies. The last thing that they have to consider is what sort of protective coating around the sensor will be needed. And according to this article, most consumer-grade cameras would use something like standard plate glass or some form of standard glass in front of the CCD. But the reflection losses at the surface of a window made of standard glass is ultimately too high to be able to see down into the wavelengths that they want for such a telescope. So it certainly looks like what they would end up using in this case would be some form of quartz coating. So, as always, everything that I see about flat Earth shows me that its proponents make their assertions based on assumptions, presumptions, and they show a lack of study, logic, and reasoning. And whatever we present to them, if it can be understood relatively easily, they will just simply reject it. And what they don't understand, they turn around and mock out of ignorance. That's going to be it for now. If you like the video, I would appreciate the thumbs up, the subscribe, comment below, share on social media, all that other good YouTube stuff. With that, I'm going to see you in another video soon enough. So bye for now.